Okay, we're going to be talking about some domain and range, and this is the introduction, and we're going to do more videos, but this is just the beginning. The domain and range of a function, and just recall that the domain are your inputs or your x value, your range are your y's or your outputs. And we're going to use a graph to find domain and range, and we're going to find domain and range algebraically. Okay, if q equals f of t, then the domain of f is the set of the input values t, because if you recall here, the point here is going to be t, q, and the input values also could be x. The range is the corresponding set of output values, or your y. So I made this little F machine picture here, and if you'll notice, I've got the domain are your x's or your input, and then you have your F machine where you do the work, and out comes your range, your f of x or your output. So this kind of shows you the basics of domain and range. The domain is also your horizontal x values. So let's write this down. Horizontal x values. And your range are your vertical or your y values. Alright, some of our domain and range basics that we have. The domain of all polynomial functions are real numbers. So what we usually like to say a polynomial function is, I'll give you an example, would be something like y equals x squared plus 2x plus 2, or y equals 3x plus 4, for an example of a polynomial. And if you have those, the domain is all real numbers. So how we write domain is I do d colon for domain, and we can say it's all real numbers. And when you write the r for reals, it's like 2 lines, and for the r, so I know I'm talking about reals. So this is the first one. The second thing we talk about for domain is the square root functions cannot contain negative numbers. So what I always ask is, are you worried? So if I have a radical, so there's my question, okay, if I have a square root function, a radical, so this is the radical, or here if I have a fraction, so for 2 and 3, the question I'm going to ask is, am I worried? Okay, so if I'm worried, then I know there's going to be a restriction on my domain, and I can't have any negative numbers underneath a radical, so that's going to restrict what's going to go in my F machine. So what you do is you set the expression under the radical, or the guts if you will, greater than or equal to 0, and then solve for it. That will be your domain. So we're going to take x plus 4 in this example right here, and you're going to make it greater than or equal to 0, and then you're going to solve for x. So I have x is greater than or equal to negative 4. That is the domain. So that's kind of neat. You can do that algebra and find out what your domain is going to be. Rational functions cannot have functions, or fractions if you will, cannot have zeros in the denominator. And so in this case, you determine which values of the input cause the denominator to equal 0, and then your domain is everything else. So in this example, you take the denominator and you say it cannot equal 0. That's 4 right there. Write that again. So x plus 4 cannot equal 0. Okay, subtract 4 on both sides. So x cannot equal negative 4. So how you do this domain is I can say it's all real numbers, but I can't have a negative 4. Do you see the difference? This one is everything else, but this one is telling you can only have x is greater than or equal to negative 4. So those are the basic 3 rules for domain. So you can do some algebra for these. Okay, now this page I put in here because this actually tells you the notations, and we're going to use set notation for domain and range, and we're also going to use interval notation. So let's talk about set notation. So here's set notation. Things that you're going to use for set notation, and you don't need to use this x, this stands for such that, I won't make you do that this time, but you're going to do like, you're going to use x is less than or equal to. You can say x is an element of the reals, or just say all real numbers. X is greater than something. Y can't equal something. Those are all things that you can use for set notation and that you've done forever, okay? Now interval notation is based on the number line. So here is, right here's the number line here. So this goes to infinity, this is negative infinity, and zero's in the middle. What you're going to do here is, if it's not included, you're going to use parentheses. If it's included, you're going to use brackets. So this is the same as when you used to have open circles on your number line. This used to be the same as closed circles because it's included. All right. We're going to also use negative infinity and positive infinity when we discuss that. So for example, all real numbers in set notation is the same thing as saying negative infinity, comma, positive infinity. So if you'll notice, I use parentheses because infinity you never get to, and this goes from negative infinity and it's a comma infinity. It looks like a point, but basically you're talking about this entire number line right here. So all real numbers and this notation mean the exact same thing, but this is interval notation and this is set notation. All right, so I'm gonna have you write it both ways. So let's practice 3 of these so you get the idea. So the first one is, I have a polynomial, and this is a polynomial function. I look at it and I say, okay, am I worried is the question that you ask. Am I worried? And if I see a polynomial, I see I'm not very worried because there's no radicals or fractions like we have down here. So no, I'm not. So if I'm not, I know the domain is going to be all real numbers. There's no restriction. I can just put all real numbers. Now the other way to write that in interval notation is negative infinity all the way to positive infinity. And again, I'm using parentheses because you never get there, and that covers the whole number line. So I wrote it in both notations. Okay. Now the other thing is if I were to graph this, and that's one thing you're going to have to do on these, is graph them and look at it, you'll notice that this entirely uses all the y-axis. So basically the range can be the same thing. It's all real numbers, and negative infinity to positive infinity. But for ranges, you need to graph. So basically for range examples, you're always going to have to graph and look at it. Okay? Okay? Now this one is 2 minus, I am worried here. Yes, I'm worried. I'm worried here, and I'm worried here. So here I know there's a restriction in the domain, so the algebra we do is we take the guts of this, and we're going to make it greater than or equal to 0. So the work is going to be 2 minus 3t. Is greater than or equal to 0, and then I'm going to solve for that, so I'm going to subtract 2 on both sides. So I have negative 3t is greater than or equal to negative 2. When I divide by negative 3, that switches the arrow, so I have t is less than or equal to 2/3. That is my domain. T is less than or equal to 2/3. Now how do I write that in interval notation? Now think of a number line. It's going to be everything negative all the way up to 2/3. So you write it this way, from negative infinity all the way up to 2/3, and including 2/3, so I put it like that. It's written just like a number line. The range on this one, if I were to graph this, I would see that, and you have to use g of t if you're talking this, is g of t is going to be greater than or equal to 0. And we're going to practice more of this, and how I write that is going to be 0 to infinity. And the last one I'm worried about, again, because I have a fraction, so I take the denominator and figure out what I can't have, and it can't be 0. So when I factor this, so I got p can't equal 2 and p can't equal negative 2. So I have 2 holes in this. So when I write domain, for the set notation, I go, I've got all real numbers, but I can't have negative 2 and 2. That's an easy way to write it. Now the range on this one, excuse me, the other way to write this domain is to write it this way for interval. So I'm going from negative infinity all the way up to negative 2 in union with, and then I've got the numbers in between, but I just can't have negative 2 to 2 in union with 2 to infinity. And we'll practice this more in class, but that's how I'd write it with interval notation. The range on this one, you'd actually have to look at the graph, and it uses all the values, so I'm going to say that h of p is an element of the reals, or we can just call it all real numbers. Let's just call it all real numbers for my range, and that would be from negative infinity to positive infinity. Again, we will go over this more in class, but this is just an introduction.